Okay, great. Let's move to question 2. Okay, a bit fast. Calculate. So we've got this expression. What we need to do is to remove the brackets. We must first remove the inner bracket. So basically, this normal bracket and this square bracket, basically they're just the same. They're just brackets. We'll differentiate them so that they are, they are visibly easy for us to identify the inner and the outer bracket. Sometimes you may also have the curly bracket if you've got more than 3. Okay, so let's remove them. First step is first to remove the bracket inside. So we first have to remove this one inside, right? The rule is simple. So we look at the number in front of the bracket and then we multiply. So we use the distributive law, right? That is it. So like this number is positive. The 3 is positive because 3 doesn't have a sign in front. So we can then multiply with each terms inside like that. That's how we break the bracket. So let's do that. And as we do so, we're going to have minus 4. And then we write the square bracket. And then the next term is 3. So we need to multiply. 3 times negative 6 is negative 18. And then we also multiply 3, positive 3 times positive 2. So it's going to be positive 6. And then we carry on. Minus 5 times 3, right? So we can calculate. So I'm sure here we don't calculate with we don't use the calculator. So here they would like to see how you can remove the bracket and apply this BODMAS law. So you can see here multiplication will precede addition and subtraction. If we want, we can multiply this already. So we can multiply this minus 5 times 3, and this gives us negative 15, right? So we can first write it by multiplying everything. So we got minus 4. Now, because we don't have an inner bracket, so this square bracket is basically like a normal bracket, right? And we write everything inside. Is minus 18 plus 6 minus 15. And now we can do the same. We can multiply. We've got a choice. Either we distribute with all these terms, or we can decide to reduce the terms inside and then multiply with the outer number, right? So we can decide to distribute. That's going to be a lot of work to distribute it now. Let's first reduce what's inside the bracket. What inside the bracket is, if you want, you can just take a calculator if you're not sure about yourself, so that you don't waste much time. And here it will be minus 18. Let me just move the calculator on this other side. So you can just use, okay, let's decide minus 4. You open the bracket. And then we've got minus 18 plus 6 minus 15. Close the bracket. And this gives us 108. So let me just write the answer here. The answer is 108. Right? And let's see how many marks was that. 3 marks. So that is fine. Now let's move to the second question. Prime factorize the following. So we are asked to prime factorize 245. So this is how we do it. 245 and 175. All right. So that we can find the lowest common multiple and the highest common factor. So we first need to factorize it. Let's do it quickly. So we always start with the lowest number, which is 2. Can we divide this by 2? No, because it ends with 5. We only divide by 2 if it ends with an even number, 0, or an even number. So 0, 2, 4, 6, and 8. Since it ends with 5 here, we must first ask if we can divide by 3, right? Now, can we divide this by 3? Well, a number is divisible by 3 if the sum of it is a multiple of 3. So the sum of 2 plus 4 is 6 plus 5 is 11. Is 11 a multiple of 3? No. So the divisibility of 3 fails. By 4, okay, a number is divisible by 4 if the last 2 digits is divisible by 4. So 45 is not divisible by 4. Therefore, it's going to fail. The next prime number we're going to use is 5. With 5, we are sure we can write 5. Why? Because it ends with 5. Okay? Divisibility of 5 can work if the last digit is either 0 or 5. So we choose 5. And now we can say if we divide by 5, it's going to be, okay, looks like it's going to be 49. If you're not sure, you can use the calculator. You just use 245 divided by 5 and equal is 49. So I was right. So it's going to be 49. And with 49, because of the counting I've done, or you have all done in primary school, it's not gonna work with anything, because previously it didn't work with anything below 5. So we need to check 6. It's not gonna work with 6, but it's gonna work with 7. And it's gonna give 7. 7 is gonna give 1. Okay, so in other words, let me just try to, okay, I deleted all. No, I wasn't supposed to delete. In other words, 245 can be expressed as these factors here, these prime factors, is 5 times 7 times 7, which is 5 times 7 squared. So we got this. So we do the same with this number. So we finish with 245. We do with 175. Okay. So we start by 2. It's not gonna work. By 3, divisibility is 1 plus 7 plus 5. It is 8. It is 13. 13 is not divisible by 3. So it's not going to work. By 4, it's not going to work. By 5, yes, it's going to work because the last digit is 5. Either 5 or 0 will work with 5, right? Now, what are we going to get here? Definitely going to get, so we don't have to guess. We can just take our calculator. 175. Okay, let me just, we're supposed to delete first. AC, so 175 divided by, no, what am I doing? Okay, 175 divided by 5. So it's 35. Yeah. 35. So by 5 again, it's going to be 7. By 7, 1. So what have we got here? With 175, we break it down as 5 squared times 7. Okay, so now we are able to find the lowest common multiple, right? And the highest common factor. Now, the lowest common multiple. So basically what we do, we take any factors that we have, we must have it, we must write it. if it's 5, we start with 5 and we take the highest exponent. Here the exponent of 5 is 1, here the exponent of 5 is 2, so we write 2 times. The next prime factor is 7, and then we take the highest exponent is 2 as well here. So this is it. What is our highest common factor? The highest common factor is the way around. We want to take the lowest amount of exponent. So the factor here we have is 5. They must be on both sides, right? So we've got 5. We've got the exponent here. If it's not written, it means it's 1 times. And then the next one, we've got 7 here with exponent 2, 7 here with exponent 1. We take the lowest, so it's going to be 7. So there it is. So we found our lowest common multiple and we found our highest common factor. Okay, but we could have spent less time to find this using the calculator. So I'd like to show you another way. If it's very tedious for you to do this factor like this manually because your times table is a bit poor, so in that case you can just use the calculator. I'm going to take the calculator here. So what I do, I'm asked to find, if I'm asked to find, let me just AC. I'm asked to find this. So we are here. So we are here, 2.2. We need to find, to prime factorize the following. So we need to factorize the following. So what is the factorizing 245? What is factorizing, prime factorizing 175? So how do we get it? How do we get this? We just take our calculator. So let me move it on the side. So I'm just going to write 245. This is our first number. And I'm just going to enter it because I want it down below. And now I'm going to use this. Let me just shift here. You can see fact is written fact here. Okay. So I need to press on shift, then press on this button here, fact. So it gives me the factors here. So this is our answer, right? Right here. So we found it. We found the first one. So we can just write it right there. So it is 5 times 7 squared. This is what we found already. And then we do the other one again. So let's turn it off. Let's start. So we got 175. We equal for it to come low, and then we shift. We go to the fact, and there it is. So the answer is going to be here, 5 squared times 7. Okay, and from here it becomes easy for you to get the lowest common multiple. In the lowest common multiple, you want to name all the prime factors. Even if it doesn't appear on either number, you need to name it here, right? So suppose there was, let's say 3 here. So we're going to have to name all the prime factors. We're going to have 3 times 5 times 7 here. Okay. And then, but on the highest common factor, you need to write the factors that are in common, that are here and there. So in this case, 5 is here. We got 5 at 245. We got 5 here. So we name 5. And then we got 7 here. We got 7 there. Then we name 7 here. But we're not going to name 3 because it only appears on one number. So this highest common factor is the intersection. You need to check what is in common. And then here the lowest common multiple is more broader. You need to take everything. Yes, you see? That is why you take the highest exponent when it comes to the lowest common multiple. So you need to take the highest exponent. If let's say 3, we had exponent, let's say 4. Sorry, if we had 4 there, sorry, that's the edge. Let me just move it a bit. If our exponent here was, let's say 4, so I would have taken 4 here. And here at 5, this 5 here and 5 here, I say, where do I have the highest exponent? Is here. Then it's 2. And then I've got 7 to 2. And here I've got 7 to 1 because it's not mentioned. So I also choose 2. I choose the highest exponent. So this name lowest can be quite deceiving. When you see lowest, that's when you need to choose the highest exponent. And when you see highest common factor, that's when you need to choose the lowest exponent. Sorry, okay? So that's how you need to kind of understand it. And I'm sure you understood. So this was just an example by adding these 3, but the result is here. The result, let me just change the color. These are the results here, right? These are the 2 results. Okay, of course, if you want to write it as a number, the lowest common multiple, you can always use your calculator and find the number. So let me go back to the calculator. For instance, the lowest common multiple now, it is 5. Where's my exponent? Okay, 5 squared. I can use this one. Times 7 squared. Times 7 squared. And then I say equal. So this number is actually, sorry, it's 1225. And then I've got our highest common factor is 5 times 7. We know it's actually 35. So our answer here. So here, the reason why you get 4 marks here, because you first have to find the prime factor of this, the first number of 245. Okay, you need first to find the first prime factor, which is 5 times 7 squared. And then you also need to find the prime factor of the second number, because some learners don't really show the prime factors of these numbers. That is why they lose marks. So the prime factor of the second number, 125, was 5 squared times 7. And now you can now find the lowest common multiple, and here we found it to be 5 squared times 7 squared. And if you use your calculator, basically it's 1225. And now you can also find the highest common factor here, which is basically 3. So we found it to be, 5 times 7, which is 35. So this is it. So I hope it is well understood. Now let's move to 2.3. It says, answers the question below. Simplify the ratio. Okay, so we can also simplify this ratio. So it's the same idea. If you want, you can just prime factorize both sides to understand what are the common factors so that you know how to simplify them. But already I know that here there is 3 and the 17, right? There's a 3 times 17, 2. I'm sure there is 3 times 3 times 17, right? So if we simplify on both sides, remember a ratio is basically a fraction. So you can take it as 51 over 153. Okay, what is the simplest way to simplify this? I'm sure it's 1/3. Or let's see if we can do it with a calculator, right? If I've got, let's see if what it's going to give us. If I've got 51, and then I use a fraction over 153. If I say equal, there it is, it's 1/3. So remember, the numerator represented the left side, the denominator represented the right side. So basically, we succeeded to simplify this. So our ratio basically is 1:3, right? So let me write it down here. I need to remove this because this seems to suggest as if we have a fraction here. Okay. So let me do this. So basically, the simplified ratio basically, it's 1:3. Because 1 now represents this left side and 3 represents this. So we simplify this ratio, right? Now let's move to the next question. The next question, my family traveled 300 kilometers at speeds of 60 kilometers per hour. How long did they travel? Okay, this is a very easy piece of exercise, okay? So the answer, okay, you don't need to remember the formula. The formula is right here. Speed, right? So it says speed is equal to 60 kilometers per hour. Remember, per simply means is the fraction bar. So this is a ratio again. This kilometer per hour. It means for every hour, for this kilometer, there's an hour, right? So you can express it like this. And when you write it like this, it gives you the formula basically, right? Speed is equal to, what is kilometer? It's a distance. What is hour? Is a time. So it means speed is basically distance divided by time. Just this phrase gives you the formula you need to use. You don't need to remember or memorize in the formula. Okay? So then we just need to apply this. The speed equals distance over time. And now we just have to replace from what is given. What is it given here? My family traveled 300 kilometers. 300 kilometers is a distance. So this is given is 300. And then what else? At the speed of 60 kilometers per hour. What else is given? This S, the speed, which is 60. And then it says, how long did they travel? How long means what is the time? We need to find the time. So let me rewrite again this expression. So basically, we've got 60 equals 300 over time. Okay? So in mathematics, how do you write time here as the subject of this formula? What do you do? Okay, you can just multiply by t on both sides. So you can multiply by t here. So whatever you do on one side, you need to do on the other side. And then these two will simplify, right? Or I'm sure, yeah, you can just do that. Or what you can simply do, so basically what you're going to have t, so 60t will be equal to 300, right? And then to find t, you need to divide by 60, and you divide by 60 on both sides. These two will simplify. You have now t equals 300 over 60, which is 5. Remember, the time here is given in hours, right? How do I know the time is given in hours? Because the speed was given, specified as kilometer per hour. Kilometer per hour. So the time here is in hours. So this is our answer. Right, so I'm really sorry I'm writing all over the place because I realized that I didn't have more space on the right. I've been writing a lot. Yeah, so bear with me with all this mess. The most important thing is for you to understand, right? I think I'll make sure that I try to put my writings in order. Okay, great. Now let's move to 2.4. So we are right here now. Here, 2.4. Simplify without the use of a calculator and express or write the answer with the positive exponents. Okay, so I'm going to do it fast here. So we're going to simplify without the use of a calculator. What do we do first of all? For us to do it nicely, we first have to do one thing here. This 9 is not written as a prime. So we know 9 basically is 3 squared, right? So after doing that, now everything now will have a prime base. 2 is a prime number. 2 here as a base is a prime number. Now only 9 wasn't prime. So now it's perfect now. Now after doing that, what we do, we just do the law, the exponent law. The exponent law says a exponent n times a exponent m. When the bases are equal and there's multiplication, what we do, we just replicate the same base and we add the exponents. So let's say if we had 2 here, let me just, to be more specific, if we have 2 here and a exponent 2 and a exponent 3, we'll end up having a exponent 5. That would be the answer there. So we do the same here. So we'll only have 2. So what are the factors with 2 as a base? We've got 2 here. Let me just change the colors. We've got 2 here. We have 2 there. And that is all. So what are we going to do? We have to add up these exponents, right? What is 2 plus negative 3 is negative 1. And then we have another exponent. Let's handle other bases. So we have this one, which is 3 squared times, the colors are not contrasting. I need to have, let me take blue. So I've got 3 to 2 times 3 to negative 1, right? So what am I going to have? I'm going to have 3, 2. I need to add the exponent. So I've got 2 plus negative 1. And I'll end up with 1. So the final answer here will be this result. And this result gives us a fraction because there's another exponent law which says if your exponent is negative, basically what you essentially have is a fraction. Let's say if you got a exponent -5, what you have is basically, to make the exponent positive, you need to bring this power in the denominator, right? A to 5. So it makes sense like that, right? So this power can just be moved into the denominator so that it can have a positive exponent. So we're going to have 3 to 1, because this would stay here, and then 2 to 1, which is 3/2. So that's the correct answer. So the final answer here is 3/2, which is 1.5. I think I don't really like the amount of space that I didn't have. I think what I should have done is to erase on my right side so that I can have enough space. So let me just clear it again. I think I should have done that. Let me just erase this. Okay, let's erase this and clean up. Okay, let's clean up all this. Okay, great. And maybe the faster way to clean up is to use this. Let me see. Delete here, much faster. Okay, great. So basically, this is what we found. So our answer here is more clear now. So here we had 2. So this is like base. So 2 to -1 times 3 exponent 1. And then what happens is this power is brought under the denominator, because on the denominator we always have 1 if it's not mentioned. So as it moves down like this here, so it's going, we'll have this one, this 3 to 1 remains as a numerator, and here this becomes 2 to 1, or we don't mention it because it's 1. Just like here, this one, we didn't mention it because it's 1. It doesn't really change. And this is our final answer, right? Now let's move to this exercise. So the first thing we've got to do is go to the denominator, because we've got an exponent inside the bracket and the one outside the bracket. And then we also have our exponent law. Remember, this exponent law, I can resume them very fast, just to recapitulate quickly, because exponent is very important topic. So I've got, let's say, a exponent 2 times a exponent, let's say, 5. What do I get? Basically, the law says I must just add up the exponent. It's going to be 2 plus 5, which is 7. That's the first law. Second law, if I've got, let's say, a exponent 7 divided, if it's division, okay, divided by a exponent 3, basically what I'm going to have is a subtraction. I'll subtract from the numerator. So this exercise can also be written like this. It's the same with a exponent 7 over a exponent 3. It's the same thing. So what do I get here is a exponent 7, so the exponent on the numerator minus the exponent on the denominator. So which will be a to 4. So this is the same result here, a to 4, right? So this is the second law of exponent. Third law of exponent, we've got when I have a exponent 3 and everything exponent 4. So the law says I need to multiply the inner times the outer exponent. So it's going to be a exponent 3 times 4, which is a exponent 12. So these are very important laws. I can also mention maybe what is a exponent 1? It's just a. And then I can go up again. Let's say mention this 5. What is a exponent 0? It is 1. Right? I think here you've got all the laws. So now let's come back here. Let's come back to this exercise because I was just recapitulating quickly for you to remember all these laws. Now, in the denominator here, we need first to solve law number 3 here to remove for us to join the inner exponent and the outer exponent. So here, this 2 exponent 2, everything exponent 3, we need to replace it with just 2 exponents. The law says we need to multiply the exponent inside to the one outside. So it's going to be 2 to exponent 6. Now, by doing that, we can now solve. Let's just replace now everything. So now our fraction, the total expression becomes 2 exponent 4 times 2 exponent 5, everything over 2 exponent 6. Okay. Now, what is the answer? Well, the first law and the second law helps us to find the total answer. So the total answer will be 2. The first law says if the exponents are multiplying, the base, like base, because the bases are the same, we need to add. We add up. So that means we'll have 4. 4 will add up with 5. But the one on the denominator will be minus. We subtract. That's what we found here, right? The 3 subtract. That is all. So the final answer would be 2 exponent, this will be 9 minus 6, which is 3. So this is the final answer, right? So we found that. Let's just go quickly. 2.5. 2.5 seems to be financial math. Financial math is also very easy, very understandable. 2.5. But let's deposit 4,000 into a saving account for 5 years. So where the interest paid on the saving is 6% per annum, compounded annually. Cindy deposit 2,000 into a savings account for 10 years, where the interest paid on the savings is 9% per annum, compounded annually. Who will have saved the most money? Okay, for you to understand this question, you need to have understood your financial math, and I would like to recap quickly in financial math. Let me first delete this so that I can have more space to explain. Okay, so what do you remember about financial math? You remember 2 things. First of all, you remember in compound. Okay, let me go back here. You first remember compound interest. In compound interest, before I even talk about compound interest, let's talk about, so in financial math, we have time, first of all, we have the principal amount. Okay, this is the amount we want to build so that it can accrue. Okay, so we have always the principal amount. We denote it by P, like an amount that we would like to deposit at the bank so that it can mature with interest. It can increase, so that's the principal amount. And then we also use the term N. N denotes time, it's time. So it's time in years. So if N is 1, it means it's 1 year. And then we also use the interest rate. The interest rate is denoted by I. The interest rate is expressed in percentage. Remember, percentage is a fraction. Percentage, if I say, let's say, if we say 6%, basically it's the same with 6 per is a fraction bar. Per cent. Cent is basically is 100. When I say 6%, basically what I'm telling you is 6 over 100, right? And that also can be expressed as a decimal. What is 6 over 100? It means it's 0.06. So this number and this fraction is basically the same thing. And these writings. Okay, so you can write. So 6%, 6 over 100, 0.06 is the same quantity. These are very important because these are small issues where a lot of mistakes happen. Okay, now let's remember quickly. So in grade 9, already in grade 8, I think you saw the simple interest. So simple interest formula, it means for you to get your accumulated amount, you see, if you put your principal amount at the bank, okay, and then given a certain interest rate, the bank would propose you or someone would propose you at a certain duration N, this is how you're going to obtain the accumulated amount. Okay. And what about a compound interest? Compound interest. So for the same accumulated amount, given the principal amount that you deposit, is going to be 1 plus the interest rate exponent. And here the time becomes an exponent. That's basically the difference between the two formula. I would have liked to explain intuitively the difference between the two, but the time, I don't want to make this very long. Okay, but I can, as I say, I can explain in detail with the next video so that you understand. So let's just solve this so that we understand what's going on. So what does it say? It says Palesa deposit 4,000 in the saving. So looks like we've got two cases here. Let me just move it like this. We've got, so we have 4,000 that is deposited, okay, into a saving account for 5 years, where the interest paid is paid as 6. And then they say compounded annually. So we would like to use a compound interest first. So compound interest means we're using this formula here. So the 4,000, so the principal amount is 4,000. So we write the principal amount here. So we open the bracket. We're going to have 1 plus. The interest rate we are given is 6%. 6%, it means 6%. And if you use this in a calculator, you can take your calculator. Or if you don't believe me, what you can do, you can take the calculator here. you can write, do I have percentage here? Yeah, I have percentage here. You can just use, is right here. Okay, let me see. I wanted it to circle so that you're able to see. Percentage is right here where there's open bracket. So we use the shift button and use percentage. If you say equal is 3/50, we can say equal again. Okay, let's say answer. No. I think there's a way for it to write in decimal again. Okay, it doesn't matter. I think I'll find how you can express the answer in decimal. It's fine, but it's the, as you can see, the answer here was 3/50. And then okay, I haven't been using a calculator for a long time. We find it out. So basically this one, 6/100, is basically 0.06. Same number. So this is what we're going to use here, 0.06. We close the bracket. And then it says after how long? 5 years. So n is 5. So we use 5 days. So this is the first case. This is where Palesa deposited first. This is the first scenario. So we need to get what is the accumulated amount there. Now in the second case, so here the first case, it was a compound interest. Okay. Now in the second case, looks like we got a simple interest. How do I know we got a simple interest? Well, because no. We don't have a simple interest. It also say compound annually. Okay, the first case, it was compounded annually. The second case is also compounded annually. So we have compound interest on both sides. Great to note it. Okay, so we also have compound interest. Now, on the second scenario, she deposited 2,000. So this is our principal amount. We open the bracket. So we're going to have 1 plus. What was the interest rate? It's 9%. So it's going to be 0.09. We close the bracket. For how long was it? It is 10 years. Okay. Who will have saved the most? Okay. So here we have Palesa. And here we have Cindy, sorry. So let's compare who would get the more return. Where are we going to have the most accumulated amount? So what do? We take our calculator, and then we're going to have, first case, 4,000, open bracket, 1 plus 0.06, close brackets, and then exponent 5. So we're going to use this button here. For exponents, we have, which button for exponents? We have this one, exponent 5. So equal. This is the answer we find in the first case. So the accumulated amount here will be, okay, 53.52. Uh, 53.52,9. Okay. So we can put it in rand. Now, what about the second scenario? So let's reset. So we'll have 2,000. Open brackets, 1 plus 0.09 close brackets exponent 10. Okay, so the second scenario here, we're going to have 4334. No, not sorry. So it's 4334 72. It's actually 47. So basically, these are the two amounts we got. And now, who will have saved the most money? So you understand how you're going to be marked. They will see how you use the first formula, the result, another mark, second result, second formula, and then the result. That's already 4 marks. And then the conclusion. The conclusion, I see now, I compare these two amounts, I see who's going to save the most, who will have saved the most money. Okay? Who will have saved the most money? So looks like it's going to be Cindy, because Cindy initially only deposited 2,000. Now the return is 4.7. Okay. So what do you think here, guys? Who will have saved the most money? Is it Palesa or is it Cindy? Who has the most return? Here it's Palesa. So the answer is clear. It's going to be Palesa. So Palesa would have saved the most money. Saved the most. So this is how you get the 5th mark here. So you can see, let me just change maybe in blue, because so you'll have 1 mark here, 1 mark for the result, 1 mark for the other compound interest, the formula, 1 mark for the result, and then you making the decision that this is the highest amount, therefore it is Palesa, right? And that's where you get those 5 marks. Okay, that's all for question 2, and then I'm going to do question 3.